Hello everyone and welcome back to The Farmer Was Replaced. And yeah, today we're going to play around with a little bit more code. Okay, so last time we figured out this code here, and essentially this is to harvest grass or hay, plant some bushes, plant some carrots and plant some bushes again just to get an excess of wood, and also to be able to trade the wood for carrots and plant some carrots. So just a quick overview. Yeah, so this code, we have a variable here called didMoveEast, which we default to true because we start at the 0, 0 position and we don't want it to move directly to the right here before we even go up. So we defaulted to true, and then basically we harvest as we go along. So if we can harvest, we harvest, and if it's position 1 or 3, so on the X position, so for example this position, which is 0, 1, 2 and 3, because it's 0 indexed, basically we have position 1 and position 3, which we plant bushes. And if it's position 2, which is this one over here, we then check the number of items for carrot seeds. If it's less than 1, then we trade for a carrot seed so we can plant carrots. And then if it's not soil, so if it's not tilled, then we till it and then we plant carrots thereafter. After all of that is done, after we have harvested specifically, then we do movement. So for example, if the position Y, so on the Y axis, is Y plus 1, because yet again it's 0 indexed, so get world size would give us in this case 4, because it's always going to be a 4 by 4 or a 5 by 5. It's never going to be a case of 5 this way and 4 this way. So essentially this will always give us the exact number of blocks, but the get position Y, because it's 0 indexed, we then have to plus the 1 so we can know, okay cool, we are specifically on that location. Because if we're here, get position Y would return 3, but get world size would return 4. So that's why we do the plus 1 here. So if it's either on this location here, or the Y position is 0 here, and we did not move east, then move east. So if we go up, so currently it's true, and essentially so it won't go in here, and then it would say, okay cool, did not move east equals to false. And eventually when we get up here, it will then say, okay cool, yes it is now false, and we are on number 4 here, so then move east, and then so on and so forth. Okay cool, happy. Then we go on to the code and we get the position X. If it's get position X modular 2 is equal to 0, so basically saying, is the value of the position X divided by 2, so how many times can it divide by 2 to be able to get to a 0, so without any remainder, so not a 0.145 whatever, specifically 0. So that this way we can know if we are on an even row or not. So for example, we're on position 0 and it will always return 0 in this case, so basically we moved north. Here it's 1, so 1 modular 2, which would give us a remainder, basically means that it will go into the south. So we move up here, we move south here, north here, because this is position 2, so 2 divided by 2 is 1, and basically, but the amount of times we can divide 2 into 2 is then 1, but also there is literally no remainder afterwards. And yeah, so then basically that means we'll then move north here. So this code will then basically cater for any amount of rows. Well, basically the movement code here will cater for any amount of upgrades that we do. So if it's a 5x5, 6x6, so on and so forth, it will always move up and down and move east as it needs to. Okay, so before I started this video, I looked at the unlocks in terms of what we needed to do next, and I accidentally clicked functions. So I did unlock it at the moment. So let's read up all about it. So functions, what are they? So we actually have been using functions throughout this code. And essentially the can harvest, the get position X, get position Y, and the plant, all of these with a parentheses, yeah, those things. They are, well, all of this is basically called functions, and it's a set of code that you can execute that does other things. So in theory, all of this we can put inside a function and call it, and basically exactly the same way. So how that works is you can have normal functions that just calls, and this would be called a getter, and basically all that it does is it calls a set of code to return a specific value. For example, can harvest. What the can harvest probably does is it checks, okay, cool, I am on this block. Is whatever is planted there, is it ready to be harvested? Yes or no? So true or false. And it returns then a true or false. And if it is true, then it will go into this block of code here. And if it's false, then it will just carry on, like no problem. The harvest will return, in this case, none. In other programming languages, it will return a void, meaning it does not return anything really. And the harvest is literally just a function that tells it to do something, and we don't care about the result. So in some cases, in other application programming, you might have some error handling, some try catches, so on and so forth. But in this scenario, we don't. And so this is just to do something. It doesn't return anything. The get position X with a with a curly, well, not curly braces, parentheses, that returns a number. So that's why we're comparing it to a number. And so now we have the ability to write our own functions. So essentially how it says here is use the def keyword to define a new function. So def with the name of the function and the arguments, and then the function code. So you can use the call operator, which is the parentheses, to call the function. So f24 of, well, 42, sorry, that would then physically call the function. So unlike Python, functions are defined in the global scope of any open file that can be called by their name, even if the def statement is or has never been executed. See scopes for more information on this. Okay, we'll look a little bit more into that a little bit later. Okay, you've seen built-in functions like harvest. You can also define your own functions, which allows structuring your code in a modular way. It basically allows you to give a name to the block of code so you can call it from anywhere you want. So function definitions, for example, you can define a function that moves the drone several times. So move in direction. So move in, which is a number, and in which direction. So you can literally, so this function, what this does is whenever I call this function, I can say, okay, cool, move ender. The n value is, that's just a variable, but what we pass in would be a number. So we can say, okay, cool, n equals to 5 and the direction equals north. Then basically what it would do is it would move the drone 5 times north. And that's exactly what this code does. And that means that we don't have to rewrite this code over and over and over again. We can move, write it into a function and just call the function over and over again wherever we need to. So that's also kind of best practice, because then we don't have duplicate code. Okay, so yeah, so everything I explained just now is basically here, so you can pause the video as well if you really want to read this. And then return values, so here we can then return a specific value. So remember I said the can harvest method or function that returns a boolean, which is either true or false. So can harvest would then eventually return either true or false, depending on the outcome of the plant type and whether it is still growing or not. And yeah, so that, okay, cool. Default arguments, okay, cool. So if a is not defined, then it will just default to false. So if we call f, then well, this function without any arguments, it will would just default to false. If we call it with true, then a would be true. So that's just kind of like defaults. Okay, cool. And we can do advanced function usage. So for example, here we would just return d, so we would actually return a function within a function. This is kind of getting a little bit more complicated through the programming code, but maybe we'll get there, maybe not. It depends on how it goes, but I like to keep things quite simple. And in some cases this might be required, but we'll see. Okay, functions that take other functions as arguments. So okay, so you can even pass functions through as arguments to be called within other functions. For example, if you wanted to do something multiple times, like described here, we call the function g multiple times in the for loop and then take it from there. Okay, so that's functions. Before we implement functions, I actually want to do some more unlocks. And essentially what I want to unlock specifically is trees and also watering. So we'll have a look at both of these properly in this video and take it from there. Okay, so trees. Let's zoom in a little bit. There we go. Okay, trees. Trees are a better way to get wood than bushes. They give 5 wood each. Like bushes, they can be planted on grass or soil. Trees like to have some space, and planting them right next to each other will slow down their growth. The growing time is doubled for each tree that is on a tile directly to the north, east, west, or south of it. So if you plant trees on every tile, they will take 2 times 2 times 2 times 2 equals 60 times longer to grow. So that is actually quite interesting. So that then means if we plant trees all over, then they would take way longer to grow. So that means if we wanted to, well, if we read this properly, to say, okay, cool, the growing time is doubled for each tree that is on a tile directly north, east, west, or south. So that means if we plant a tree here, we can't plant it here or here, but we can plant it over there. So if we plant a tree over there, position 0, position 2 on this one, and then position 1 here, and position 3, and then yet again for this one, position 1, or position 0, sorry, 0 and 2, and then 1 and 3. That means that they're not right next to each other, they're basically diagonal, which is perfectly fine, just as long as they're not next to each other. So, how are we going to do that? Firstly, what we need is a function to check whether we are even on the x or the y-axis and also the x-axis. So what we can do is create a function here, def, let's call it is even, And what it needs to do is we take in a variable called n. And what we need to do is very similar to this code over here, where we check whether we move north or south, is to say, okay, cool, return whether it is n modular 2 is equal to 0. There we go. Okay. So that means we now have a new function called isEven. And we can call this over and over again to do this calculation for us. Not to 0. There we go. This can then be executed multiple times with whatever we pass in here to make sure that it is even or not. Okay. Okay. So, actually, what I want to do is kind of create a new function, because I want to kind of keep it separate from this, because this is doing with the carrots and stuff like that. I don't really want to mess with that. So let's, well, I still want to keep it open though. So let's do that. Okay. Now, while true, our usual. So because we want an infinite loop in this case to do all of the harvesting and stuff like that and whatnot. Okay. I just check. Do we have the clear? No, we do not. I thought we had a, maybe I did that on my own actually. Okay, so I just whipped out a quick piece of code here, very similar to what we've done here, but this is just a harvest all and reset. Okay, and essentially what this does, so let's just hook it into here. What this does is very similar to this, and all it does is basically checks, can we harvest? Then harvest. If the ground type is not turf, so which is this normal green ground here, then till it, because we want to reset this, and then also then do the movement as per normal. So if we do this, what will happen is everything will just turn back to grass. So we kind of like have a complete reset. Okay, so now that we have that, let's move back to 0. Now we can continue with this code here. And what we want to do is plant trees. Okay. Well, let's do a tree only farm. There we go. Okay, so while this is true, we need to check, are we in an even row, or row and even column? So with the help of variables, we can say, okay, cool, is even row equals to is even, and we pass in get the position y plus 1. Okay, because yet again we are 0 indexed, and we can check is even column is equal to is even get position x. And I just want to check, do we need to do, I think, yeah, I think this will work as well if we just do that as well. But the thing is, what would also work, if I'm not mistaken, I'll try it like this first, but we might need the +1. I can't, let's test it. Let's just test it. Okay. Then what we want to do is, firstly, we need to make sure that we can move accordingly as well. So we'll copy all of this code, and then basically, so this that move east up. There we go. Forgot about that. So now our movement is still good. So very happy with that. Let's just move back to 0. Okay. what we need to do is plant the trees. Okay. What we need to take into account as well is if we can harvest. So for example, this code here, then we need to harvest. So that's our bog standard code. But also, if we can harvest, we need to plant again. So this is now where the main code comes in, is to say, okay, cool. If it is an even row, well, if it is an even column and not an even row, then we want a tree. If it is an even row and an even column, well, and even it's not an even column, then we also want a tree. Otherwise, we just want a bush, so, or grass or whatever, so anything else. So what we can then do here is say, if is even row, just want to work out the logic here, and is even column is equal to false, then plant entities dot tree. There we go. So just want to check. Let's just double check this. Oops. There we go. Okay, so we get trees over there and there. Perfect. So now we need to do the inverse as well. So if we move back to 0 again. Okay, this one I just want to move like there. Perfect. So now we need to do the inverse as well. To say, okay, cool. Elif is even row. We'll simplify this code just now. Is if even row is equal to false and is even column, then also plant a tree. So let's check this out. There we go. So now, and see how it's skipping over the trees, because the trees take way longer to grow. And basically when the trees are ready to be harvested, it will then harvest the tree. And then we basically get, I think trees give us, let's just check here. Okay, base growth time between 5.6 and 8.4 seconds, can grow on soil or turf. Okay, cool. Okay, but I think they give 5 wood each. Okay, cool. So now we at least have a tree farm, and that will give us wood. And then what we can then do now is say, to simplify this code, is do that. And because, so first thing also to remember, when combining ands and ors, we need to make sure to use parentheses for scopes. That's very, very, very important, because essentially, to give you an example, if we do this and we say or that, because this kind of makes sense, because if it is this and this, or that and that, then cool, then do your thing. But we need to evaluate the order of execution here. If this and that, or, so this or takes into account this only and not specifically that. This is where things get a little bit tricky and a little bit kind of complicated. To make this a lot more simpler is we add just additional scope to it. So for example, like that and like that, because now everything inside this parentheses would need to be true for that, or this needs to be true. So both these statements with the and would need to be true in order to execute this. So that then means we've now combined this and this into one statement here, which means we can then remove all of that. And we run this, it will still run accordingly. Because sometimes it executes this, sometimes it executes this, depending on where we are. Okay. Cool. So now what we also want to do is plant some carrots in the inverse. So we can say here elif and basically kind of inverse this. If it's not, if this is false, because that would result into that. So if both are false or both are true, if I'm not mistaken, then what we want to do is then check, let's combine that again, till the ground and all of those things. So then we basically check the number of carrot seeds, trade for carrot seeds, and then till the soil if need be, and then plant carrots. So let's double check that and see if that works. Aha! That actually works. And there we have it. So now it will also just carry on and basically harvest as we go along, and as it's ready it will then do its thing. Perfect. So now we've actually made kind of like a little bit more of a more complicated farm, but also more efficient to some extent, because bushes only gave us 1 wood each, and trees, if I'm not mistaken, give us 5 wood each. So based on the amount of space, we are a lot more efficient by getting wood, but a lot more complicated in terms of code. And what we can even do, I just want to check actually, is everything only defined in one class file? I just want to check. Let's move. Let's close this one. Okay. If I do this and I say movement class, and I do that, we need to move all of this actually to the left. There we go. And we need to basically add this. There we go. If we add this to a definition, move grown, and perhaps we pass through that move east, and then we'll move that, and now all of this can actually move like that, like so. Then we say, oh, we can. Oh, that's perfect. And then basically we say that move east. I wonder if that will work. That's the same, so we can actually remove that. So let's have a look. Let's see. Oh. What's happening? Trying to create a local variable with the name that move east. That move east already exists in an outer scope. Oh, okay. So is move east? Well, actually, then we don't need it. Like so. But we're updating it here. So Yeah, see, that's the thing. If we do a return, move east, it's not, is that move east, just to have a different name, and then we return is that move east. Returns don't have anything else, right? Yeah, okay, cool. So then we say that move east equals to that, and the move east we pass in, and so I'll explain this just now. So let's check this out. Continue. Because the continuous outside, yeah, because we did that. How are we going to do this? So the continuous only when it's true. Yeah, see, that's not great, actually. Otherwise, we need to say if that move east, then continue. And we basically, well, we would then just return that over here. No, then we don't need this actually. We just return it. Yeah. So if we move back to 0, there we go. Perfect. Okay, so what happened here? Let's move this over here because that makes more sense now. Okay. I actually quite like how this pulls in together, really. So we have a variable here called that move east. So we can check whether we did move east or not, and keep basically keep state. I'm also just wondering, does that keep state here? If we did this and do that, and we just did that, would that work? Oh, because we use the move east there. Hold on, what's wrong here? The move east have never been defined. Yeah, see. Okay, cool. So that doesn't really work for us. So we'll do that, and then there we go. That move to 0, 0. Okay, back to normal again. Okay, perfect. So we'll keep the code as is. Okay. So what happened here? We basically created an is-even definition or function just to check where we can plant things. Happy. Okay. We have a variable called that move east based on the previous movement. We're checking is even row and is even column for this chess style board to some extent what we have right now. We check if we can harvest, and if we can, then harvest. And then if we can harvest and we've harvested, then basically we check whether we are in these positions for planting trees. So even and uneven positions to plant the trees, and then the inverse of that. So saying, for example, for the trees, if it is an even row and it is an uneven column, then plant a tree. Or if it is an uneven row and an even column, then plant a tree. So that case for uneven columns and even columns, and then also uneven rows and even rows. Okay, then if it is not one of those, so for example position 0 here and position 2, we want to plant carrots. So that then means the complete inverse of this. So meaning if either both is uneven or both are even. And then basically if that's true, then we check the number of carrot seeds, cool, trade for it. If the ground is not tilled, then till it and then plant carrots. So that's why we get the carrots on the inverse position. And then because we have the variable here for that move east, we then keeping state of that, and we have now defined a function in a separate class file, which is very, very nice because that means we can just minimize the movement class, which is absolutely fantastic. And we can actually reduce this code even more, which I'll show you just now. To then say, okay, cool, we can actually move all of this code out into its separate class file just to say plant a carrot. So not to, like, that function will contain all of this logic to say till the ground, check for carrot seeds and then plant it, but all that we're doing in the main code is just say plant carrots. We don't care about the rest, just do everything for us, so on and so forth. So just taking that into account, what we can do is just add that here and we say plant carrot. Just plain and straightforward, plant carrot. And we create a definition for plant carrot, or actually it begins with a lowercase, so uppercase, lowercase and camel case. Like for functions and variables, it all depends on the programming language. So some languages do prefer functions to start with an uppercase, other languages do prefer it to be a lowercase. So at the end of the day, it also kind of, like, very much in, when I say kind of, I really mean kind of, depends on your own preference, but in most cases best practice for certain languages are out there and everybody uses it that way. And the way I like to develop here, as you've seen, is I use camel case, so lowercase from the start, and then every other word starts with an uppercase letter. So we say here plant carrot, and what we want to do here is just do all of this code right here, and we want to do that, and that. Okay, no, the if statement is there, cool, and then so basically it checks that. We need to bring that one back, so that then means all of this code can then just be turned into plant carrot, just like that. And that then is our code. So if we run this now, we can see it still works, because even though our code is in separate files, because now we're using functions, we have our movement class, we have our plant carrot class. So if we change this to plant carrot class, then it means that, okay, cool, so we have our tree only farm. This is no longer tree only farm, this is tree carrot farm. And just say, okay, cool, so we get the positioning of everything. If we can harvest, then harvest, then basically if so, then plant trees or plant carrots. So very similar to plant tree, we just pass through to say plant a tree, happy, done. If it's carrots, then we have a lot more work to do. Now in the next episode we'll definitely be looking at watering, and so we need to kind of like buy buckets of water, empty buckets or tanks, and they fill up with water every now and then, or every so often, so a few seconds or so on and so forth. And that then means that we need to have currency to trade for buckets, to buy buckets, and then be able to check if we can water, then water, because that then means we can harvest something a lot quicker. So what does that mean? That means we'll have to add more code here, and we might want to water trees, we might want to water carrots. And that code is going to get a lot more complex. So for example, we might even have an additional class here to say plant tree class. And we say, okay, cool, def plant tree. And all that's going to be in here at the moment is just that. So if we stop this and go here, then we can change this to plant tree. Because if we want to water each and every one of these, we'll probably have to say, okay, cool, water, or call a function to then basically water the ground to make sure that, okay, cool, we can water it, or we need to trade for it, so on and so forth. So we might add that as an additional class to say, cool, buy buckets and water the blocks, so on and so forth, and whether we can water, if we can't water, all that. So all that can be logic that can be added to its own function. And now you can see how we can make the main code simpler by writing additional functions that we can then now actually minimize, because we don't really care about those because they do all the work for us now. And then, yeah. So we've made amazing progress in this episode, I believe. And yeah, so we have a movement class, we have a plant carrot class, which I've moved just now, there we go. Plant carrot class, plant tree class, and the next episode we'll definitely be looking at watering to basically get more wood, or have the plants or carrots and trees grow a little bit faster so we can harvest more and more and more of it. But yeah, guys, on that note, if you like this episode, please feel free to leave a like, and if you're not subscribed, please feel free to subscribe as well to keep updated with the series. But on that note, guys, have an absolutely fantastic day, and I will see you in the next episode. Cheers.